All right, on Friday, we discussed different angles on the unit circle. What was the first thing we did? We took this unit circle
And
and we divvied up the angles. So from 0, I showed you how to break it up. So how many degrees are in a circle? 0 to?
360,
What is half of a circle?
180,
180. What's half of 180?
90,
So each of these is 90 degrees,
270,
okay? So if this is 90 degrees right here, what's half of 90?
45,
45.
So each of these is 45, right? So
Right.
from here to here, it's 45, add 45.
135,
Tell me what these are.
135,
135, and all you're doing is adding 45 to 90. Add 45 to 135, you get 180. Add 45 to 180, what do you get?
225,
Add 45 to 225, you get 270. Add 45 to 270, what do you get?
315,
And add 45, you get 360, right? So now, we can break this up into 3 sections from here to here, 30. So if you add 30 degrees to 30, you get 60. Add 30 to 60, you get 90. Add 30 to 90, what do you get?
120,
120. Add 30 to 120, what do you get? Add 30 to 150, you get 180. Add 30. Add 30.
240,
Add 30.
300,
Add 30.
300,
Add 30.
330,
And add 30. Now, so we started off with that. Then we talked about, can you construct an angle? That's the first objective, was, are you able to draw an angle in standard position? What does that mean? Can someone explain to me the difference between an angle that's positive versus a negative angle? What's the difference? Go
The
ahead.
If it's positive, it goes counterclockwise, and then when it's negative, you go clockwise.
If it's positive, he said, you go counterclockwise, and you always measure in standard position. The positive x-axis is your initial side, and your terminal side is your ending side. So if it's a positive angle, you're gonna go counterclockwise. So you have to draw an angle, like draw that little arrow, stating that you're going counterclockwise. Versus, this angle was negative 130, so you're gonna go backwards 130 degrees. And so a negative angle is going clockwise. Now, do you remember what else we talked about? Coterminal angles. What is a coterminal angle?
Like if you take a full turn around or something like that.
Yeah, it's an angle that its terminal side lands right on top of another angle. So how do you find a coterminal angle? What do? You either add or subtract 360 degrees. That was the other thing we did on Friday. So a coterminal angle, you're gonna add or subtract 360 degrees. Then we talked about a couple special triangles. Do you remember those 2 special triangles that we talked about?
45,
Let's review them. We talked about 45, 45, 90-degree triangles. We went through the ratios. We did the proof of it. We started off, this is what we did on Friday. We did that, do you remember this? We did the sides and we came up with, what were these sides equal to? 1, 1, square root of 2. Remember that? Then we did a 30, 60, 90. Here's your 30, 60, 90. And then we had 60, 60, 30, and 90. Do you remember the ratios on these?
No.
Remember what this one was? 1. double square root of 3. So if you do it if you do this the 60, this is gonna be root 3. This is gonna be 1, and this is 2. The hypotenuse is 2. The side opposite, I want you to remember this, the side opposite the 30 is the 1. So see opposite the 30, it's the 1. And the side opposite the 60 is the root 3. You guys remember this? So on this page right here, back here,
You wanna talk about it?
do you remember how we did these problems? Can someone explain how we did these? Gotta know this is important. Let's go back over it. So, check this out, number 7. So what you're going to do is look at this ordered pair, 2, 2. To go from the origin to this point, you're going over 2 units and up 2, right? Yes or no? Over 2 and up 2. So do you see this triangle right here?
Yeah.
If both of these legs are the same number, can you tell me what angle this is right here?
45.
It's a 45. So now, if a whole circle is 360 degrees, and they want you to measure from here to here, what would you do? You would do 45 minus 360. What do you get?
Negative 350.
So this is a negative 315 degree angle. Number 8. So they give you this ordered pair, negative 5, negative 5. So from here to here is negative 5 units, and here to here is negative 5 units. So if we took this triangle and divided both sides by 5, this would be 1, 1, right? What angle is this gonna be now?
45,
A
45.
45. So they want to know, what is this angle from here to here? Well, if from here to here is 45, what is this measure right here? 45. And what's this measure right here? 90. So what's this angle right here?
135.
Negative 135. Got it? Next one. Okay, so this point right here is 1 and then root 3. So you've got this triangle right here. I'm going to draw it on the side. This is 1, this is root 3. So the angle opposite the 1, what did we say that was? 30. The angle opposite the root 3 we said is 60. So if this angle right here, inside here is 60, right? Everybody see that? Say yes or no.
Yeah.
That's 60 degrees. I want to know from here to here. So what's it from here to here? 180. So what's 180 plus 60? 240. This is a 240 degree angle. Are you getting this? Okay. Next. Okay, you have a point right here. From here to here is negative root 3 over 2, and from here to here is 1/2. So I don't like these 2's in the denominator, so I could multiply both sides by 2 to get a triangle that's in proportion to that 1/2 and negative root 3 over 2. So if I multiply both of these by 2, I'm familiar with this triangle right here. Does that make sense? 1 root 3. So this angle right here, it's the one opposite the 1, so this is a 30. So if this little angle right here is a 30, what's it from here to here? If this is 30 right here, what's it from here to here?
150. 150.
You could do 90 plus 60, or you could do, anyone do something else?
180.
180 minus 30, good. 180 minus 30 is 150. You get that? Yes or no? Okay. Next, 11. So you have this triangle right here. From here to here is 2 root 3. 2 root 3, and then from here to here is negative 2. I don't like these, so let's divide them both by 2. So we have this triangle right here. I'm going to call this root 3 and this negative 1. So what angle is this from here to here? Here's the 1. Is it a 30 or a 60?
30.
30. So what's it, this arrow is going like that. Sorry, it's hard to
So
read.
it's
Negative 30 degrees. Thumbs up? Okay, next one. We've got 3, we're gonna go 3 units this way and down negative 3 root 3. So this is what you have. You have, if we divide both sides by 3, you're gonna make that a 1 and this a root 3. So what angle is this right here? 60. So what would it be from here to here? If this is 60 right
300.
there, here to here is 60, what's this?
300.
Okay, this would, from here to here is 270 plus 30 would be 300. So you could have done 360 minus 60, or you could have done 270 plus 30, either one. Are you guys getting this? Okay, next. Check this out. What do you see?
A graph.
A graph, piece of graph paper.
True.
If I drew this little bitty circle right here,
1.
that's called a unit circle.
It's got a 1. Everything
Well, I'm gonna point to this. What point is that right there?
Oh.
0, 0.
The origin.
I'm gonna blow this up because it's so small.
Well,
Blow it up. Wrong way. Okay, let's focus in. So that's 0, 0, right? What ordered pair is this right
1,
here?
0.
That's 1, 0. What point is this one up on top?
0, 1.
0, 1.
Negative 1, 0. 0, negative 1.
Okay. Now, in reference to this point, 1, 0, what angle is this right here?
What do you mean?
What angle is it? It's
360.
0 degrees or 360. In reference to this point right here,
90.
0, 1, what angle is this right here?
90 or
90 degrees. Or you could say negative 270. What angle is this right here?
180.
180. What angle is this right here?
270.
270
Negative 90.
or negative 90 and then 360, right? Now, you guys learned in geometry, this up here, and if anyone wants a copy of this, I will give this to you. You learned in geometry what sine, cosine, and tangent is, right?
Yeah.
What is it? What is the sign?
The ratios.
SOHCAHTOA.
These are all ratios. It's a comparison of, when you have a right triangle here, the word sine is referring to the side opposite over the hypotenuse. Cosine refers to the side adjacent over hypotenuse, and tangent is opposite over adjacent. Well, what does it mean by opposite and adjacent? If we're talking about this angle right here, the side opposite that angle this is the side opposite of it. The side adjacent means next to, this is the adjacent, and the hypotenuse is always the side opposite the right angle. Now, if I switched my angle over to this one right here, if I called this my angle, this side would be adjacent, this side would be the opposite, and that's still the hypotenuse, okay? So you've got to know what the word opposite means, what the word adjacent, and where the hypotenuse is. Now, if you looked at a circle, and I'm going to draw something for you. Here's your circle. Okay, if I put a circle here like that, and I said, let's say this is 45 degrees. It's a 45-degree circle. Now we're orange, or yellow. Neon yellow, highlighter yellow. Oh, back to white. If I asked you what is the sine of this angle, whatever it is, what is the word sine? Opposite
Over hypotenuse.
over hypotenuse, right?
Yeah.
Well, if I call this point 1, 1, this is 1, and that's 1. And this would be root 2. So this would be, the sine of this angle would be side opposite over hypotenuse. Well, what if I named this, because I don't want to use 1, 1. What if I wanted to call this a 60-degree angle? So this would be root 3, this would be 1, and this is 2. So this point right here would be over 1 up root 3, like that. So if I said, what's the sine of 60 degrees? Sine is opposite over hypotenuse, or root 3 over 2, sorry. Now, can you tell me another name for root 3 instead of side opposite? What is this value right here, and what's this value right here? X and Y. So instead of saying opposite, the side opposite is always going to be your Y value, and your hypotenuse is going to be your radius. So I want you to think of the word sine. Not only is the side opposite over the hypotenuse, but also as the Y value over the R value. Why do you need to know that? Because when I ask you what's the sine of 90 degrees, right here, if I ask you what's the sine of 60, you're going to tell me root 3 over 2. If I say what's the sine of 30 degrees, that's easy. 30, here's your 30, 1, 2, root 3. Sine of 30 is 1 over 2. But when I give you this location right here, where's your hypotenuse? Where's your triangle? Can you draw a triangle that's straight up and down? No. That's why you need to know at 90 degrees, this ordered pair is 0, 1. And by the way, you had a circle here, and the circle had a radius of 1. So instead of saying sine is the side opposite over the hypotenuse, and the hypotenuse was 2, because that was the radius of that circle, instead of saying opposite, you need to know it's the Y value over the R value. So in other words, 1 over 1. It's because of these spots right here, 0, 1, I'm sorry, 0, 1, this is 1, 0, 1, 0, negative 1, 0, 0, negative 1. Because of these special triangles here, no, they're not triangles, here to here, from here to here, you need to know that sine and cosine and tangent have another name instead of side opposite over hypotenuse. You got to remember, sine is the Y value over the R value. Cosine is X over R, and tangent is Y over X. Because when I say, what's the sine of 90 degrees? You got to know what the Y value is right there, which is 1, 1 over 1, and R is 1. At these 3 spots, if you're at 90 degrees, think of 0, 1. If you're at 180, think of negative 1, 0, and so forth. So, go back to your notes, right here, and I believe we did these on Friday. We did that. What's the sine, cosine, and tangent of 90 degrees? Well, you got to know where 90 degrees is to give me the ratio. If it says cosine of negative 180, you got to know where negative 180 is. Hi. Be careful you don't fall. When you walk by, wave the camera.
No regrets.
That's a single letter?
Oh, now we're purple.
Yeah.
Okay.
Go home.
Okay, so 180 degrees going backwards is still going to give you this ordered pair, negative 1, 0. So you got to know cosine is X over R. The X value is negative 1 and the R value is 1. So negative 1 over 1, which is negative 1. The sine is the Y value over the R, so 0 over 1 is 0. What would the tangent be? Let's throw that down here. What's the definition of tangent? Y over X. What's the Y value over the X value? 0 over negative 1, which is 0. You guys got this?
Yep.
Okay, so if I ask you, let's do this one, and I know we did this already, but it's not gonna hurt to do it again. Where is 540 degrees? Well, what's this from here to here?
360 and then another 180.
360. So I have to take 540,
550.
540 and do what to that?
Subtract
I have to
360.
subtract 360, because I'm looking for a what? What starts with a C? Coterminal. What angle is this?
180.
180. So where is 180? It's right here. So all the way around it should look like that. That is 180 or 540. 540 or 180. So if I ask you what's the sine, cosine, or tangent of 540, it's the same as asking you what's the sine, cosine, and tangent of 180. Well, what is the ordered pair for 180?
10. Negative 10.
Negative 1, 0. And what's the definition of sine? It's the y value over the r value. So it's 0. What's the cosine? Negative 1 over 1, which is negative 1, and tangent would be 0 over negative 1, which is 0. You got it?
Yep.
Okay, so now, the back side. Okay, I want to know, I'm now going to give you a 60-degree angle. Where's a 60-degree angle? Right there. There's your 60. So right away, you got to know the sides. Opposite the 60 is √3. Hypotenuse is 2 and 1. You got to memorize it. So now, what is the sine, cosine, and tangent of a 60 degree? Well, sine is opposite over hypotenuse. So now we're going to use the word opposite versus y over r. The side opposite over the hypotenuse.
Why do you keep changing back and forth?
Well, because if you are here, 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 and here, oops, I can't make a triangle.
Okay.
But if you are in between here, I can make a triangle. And so I'm talking about this angle right here.
So the x and y's you just apply to the graph.
Yes, it
Yeah.
applies to the
Okay.
sides.
Got it.
Okay, so if you remember sine is opposite over hypotenuse, think of it as y, the y value over the r value. So over here, it's the y value over the r value. Here it's the y value over the r value. So that's why you want to be able, you need to know if you're on an axis. If you're on an axis, you use the y over the r, or the x over the r, or the y over the x. If it's in between, anywhere else besides these locations, then you're going to use side opposite over hypotenuse. Does that make sense? Okay, so if I asked you what's the sine, cosine, and tangent of 60 degrees, I'm going to use side opposite over hypotenuse. So √3 over 2. Cosine would be 1/2, and tangent would be √3 over 1. Does that make sense? All right, now check this one out. 225 degrees. Where is 225 degrees? Help me out. Where's 225?
Where the direct diagonal.
So from here to here is 225. So now I want to analyze, you always want to analyze the triangle that you make with the x-axis, never the y-axis. So I'm talking about this triangle right here. Does everyone understand that? That
Yeah.
triangle? Now, let's use some common sense here. If from here to here is 225, let's shave off this, because I'm concentrating on this orange triangle right here. if we remove all of this, how much is this worth?
180, so
180.
245 minus
So if you
180,
subtract 180, what do you get?
45.
This angle is 45 degrees. Does that make sense? Okay, if this is a 45-degree triangle, what do you know about these two sides?
It's the hypotenuse of 90.
1, 1, root 2. Now, unfortunately, this is in quadrant 3, so this is not a positive 1. It's a negative 1. This is a negative 1. Think of your x and y axis. This is positive and positive. Negative, positive. So, in other words, in quadrant 1, if you're an angle in quadrant 1, your x and your y values are both going to be positive. If you're in quadrant 2, your x value will be negative and your y value will be positive. If you're in quadrant 3, your x and your y are both going to be negative because you have to go from here to here, here to here. These are both negative. And in quadrant 4, this is positive and this is negative. So my angle was in quadrant 3. Therefore, these two sides have to both be negatives. So now when I ask you what's the sine of 225 degrees, I'm going to play around with this triangle right here, this 45, and use the side opposite over the hypotenuse. But I'm going to use -1, not +1, because I'm in quadrant 3. And in quadrant 3, x and y are both negative. So when I say, hey, what's the sine of 225 degrees? It's opposite, so it's -1 over root 2. Opposite over hypotenuse. The cosine of 225 degrees is side adjacent over hypotenuse. And the tangent of 225 is the side opposite over the the adjacent, -1 over -1, which cancels, the negatives cancels 1. Does that make sense? Because I'm going to do these next 3 with you guys. Actually, there's 5 we're going to practice right now. Okay, so here's got it. -45 degrees. Can you draw a -45? This is from the LATs from section 13.2. I need you to construct a -45 degree angle for me. Where is it?
It's like going 315.
It's in quadrant 4, right? This is your -45 degree angle. So if you're in quadrant 4, and this is a 45er right here, 45 degrees, can you name these two sides?
1, 1.
1, and then what's this?
-1.
-1. Now, why am I calling this -1?
Because you're in the fourth quadrant.
Because you're in the 4th quadrant and the y value is negative. So in reference to this angle, what would be the sine of -45 degrees? Opposite over hypotenuse, so -1 over root 2. What would be the cosine of -45? Adjacent, which is a +1 over root 2. And what would be the tangent? Opposite over adjacent, -1 over 1.
-1.
So it's -1. Okay, questions? How about the next one? Where's 150 degrees at? Draw it
30
for me.
off of 180.
Okay, so here's 150. Okay, I don't care about from here to here. I need to make a triangle with quadrant, with the x-axis. I'm gonna do this for you. Let's play around with that triangle right here. So if from here to here is 150 degrees,
Do you have Shemaiah Hall in here?
yes I do. Thank you.
Stay out of that.
If from here to here is 150, what is this
30.
bitty angle here? 30, right?
30.
So now, if this is 30, what are we gonna name this?
For opposite.
1.
1. What would this be called? -√3, and this is 2. Now, if you don't know where these numbers are coming from, that's from geometry. It's from geometry. So now, if I say, what is the sine of 150 degrees? What's the definition of sine? Opposite over So what's the answer?
1/2.
1/2. What would be the cosine of 150?
Negative root 3.
Excellent, negative root 3 over 2, and what would be the tangent? It'd be 1 over negative root 3. Now, when you get to pre-calc next year, you're gonna do these same problems, but I'm gonna expect you to rationalize the denominator. Don't worry about it right now. That's not my concern at this point. Okay, we'll build up to that. Okay, let's do these together. 26. I wanna know what's the sine, cosine, and tangent of what? They gave you a picture, I'm not gonna tell you. What is that?
30, 69.
Okay, what angle is it? Negative 60. So you're gonna draw a triangle like that. This is negative 60, so you always make your triangle with the x-axis. So if this is 60 right here, can you name these two sides?
2,
Where's 2?
the right,
Wait, where?
opposite of 60.
Is what?
2.
No,
No,
Square root of 3.
3.
it'd be negative root 3. What's this side right here? 1,
2.
And 2. So now, what's the sine of this negative 60 degrees? Anybody?
Opposite over hypotenuse.
Negative root 3 over 2. What's the cosine? 1/2. And what's the tangent?
Opposite.
Negative root 3 over 1. Do you get this?
No.
Yes?
Yes.
Okay, next one. What kind of angle is this right now? Right now?
45, 90.
It's a positive 135 degrees. What quadrant are you in?
Quadrant 2.
You're in quadrant 2. That's not working. I need to know what angle this is right here. So from here to here is 135. What's this bitty angle right here? 45, thank you. What do you know about the ratio of the sides opposite and adjacent of a 45? They're both the same, 1, 1,
So, is it -1?
but you're gonna name that -1 because you went left 1. Does that make sense?
Yeah.
Okay, now what's the sine, think of this. What's the sine of this angle right here?
It's 1 over root 2.
So sine of 135 is gonna be opposite over, so it's 1 over root 2. What's the cosine of 135?
-1 over 2.
Yep, and what's the tangent of 135?
1 over -1.
Mm-hmm. 1 over -1, which is -1. And the last one, you've got a negative 390 degree angle.
So negative
That's a
30
little
degree.
crazy for me, so what do I do?
Can I click on that?
Whoops. Negative 390. Thank you, who said that? Ashley,
It's -30.
it's what?
-30.
So that's what I'm concentrating on, is this triangle right here. This is 30 degrees right here. What quadrant are you in?
4.
4. What do you know about these two sides? One of them's gonna be positive, one's gonna be negative.
-1.
-1 right here, root 3 and 2. Does everybody understand that? I'm gonna draw it over here. This is kind of messy. This is gonna be root 3, from here to here is root 3. This is gonna be -1, and this is 2. So if I say, what's the sine of negative 390 degrees? What are you gonna tell me?
Opposite over 2.
Negative 1 over 2.
-1 over 2. What's the cosine of negative 390?
Root 3.
Mm-hmm. And what's the tangent?
1 over 2.
What is it?
Or 1 over root 3.
It's -1 over root 3. Does anybody not understand this? Does anyone have any questions? No? Okay, so what I'm gonna have you guys do today,
No.
Stop recording.
you can stop recording. I'm gonna